Euclid's Elements, Book 2, Proposition 8. If a straight line be cut at random, 4 times the rectangle contained by the hole in one of the segments, plus the square in the remaining segment, is equal to the square on the whole, plus the aforesaid segment as on one straight line. We begin with our straight line, AB. We cut it at random at C. And then what we're going to do is extend out in a straight line. We'll go out to D, but we're going to make CB equal to D. So prop 3, book 1, we're able to make BD equal to CB. Now, we can lay out what we're actually trying to show, and that's that the rectangle contained by AB, BC, so the original hole AB, BC, plus the square on AC, is equal to the square on AD. Sorry, that's 4 times. 4 times the rectangle. So 4 times this rectangle plus the square on AC is equal to the square on the whole AD. First thing we do is we draw our square on AD. And then he says, now we just draw our figure double. So what we've been doing the last 4 props, we do again here, but we just draw it double. So we utilize proposition 31. First of all, we draw our usual diagonal. We'll call this EF. You can do that by postulate 1 of book 1. And then using proposition 31, we start drawing a bunch of parallel lines. So we start off, we draw through C, a line parallel either to DF or AE. We do the same thing through B, parallel to either DF or AE. And then through these intersection points, we draw two more parallel lines. EF, G, H, I, J, K, L, M, and N. And we'll call these down here O and P. Okay. So we write up here that GJ is parallel to AD, that KN is parallel to AD, that CO is parallel to DF, and that BP is parallel to DF. Now we know that CB is equal to BD, and CB is equal to HI, which means that HI is equal to BD. But BD is equal to IJ, so all these lines CB, BD, HI, and IJ are all equal to each other. And now we can apply proposition 36 twice. Proposition 36 says that parallelograms on equal bases and in the same parallels will be equal. So we have the figure CI and BJ, which are on the equal bases CB and BD, and therefore CI is going to be equal to BJ. and then HI and IJ equal bases. So the figure HM and IN will be equal. But according to proposition 43, if you look at the parallelogram CN, it's got a diameter DL, and then you've got the complements CI and IN about the diameter. So that means that CI is equal to IN, which means that all of these figures, if you combine steps 5 and 6 here with common notion number 1, we can say that all 4 areas are equal to each other, which means that 4 of them together would be 4 times one of them. Therefore, he says that the 4 areas are 4 times CI, 4 times the figure CI. And now we're going to do the same thing, or something similar, with all the figures AH, GL, LP, and MF. So we know that CB equaled BD, but BD equaled BI, and BI equals CH. But we know that CB equals HI, which equals HL. So by a whole series of common notion number 1s, we get to CH being equal to HL, and then we can also show in the same way that LM is equal to MN. So we'll write out that CH, line CH equals HL, and we can say that LM equals MN. Now we can, step 9, since CH and HL are equal bases on which the figures or the rectangles AH and GL stand, and they're in the same parallels, namely AE and CO, then AH is equal to GL. That's proposition 36. So AH equals GL. But with the same proposition, we can see that LM and MN are equal bases, and they have LP and MF standing upon them in the same parallels, namely KM and EF. So that means that LP and MF are equal to each other by the same proposition. So LP equals MF. But if you look at the parallelogram GP, which has the diameter IE, we can see that GL and LP are complements about the diameter. So according to proposition 43, GL must equal LP. The complement GL equals the complement LP. But that means that all of our complements, by common notion number 1, all 4 of these complements are equal to each other. So we'll write that up in step 11. So we can say that AH equals GL equals LP equals MF, which means that all 4 of them together are 4 times one of them. So they'll be 4 times, we take them all together, all 4 complements are 4 times AH. So that means if we just added CI to AH, and we get this long rectangle AI, all of the complements together plus the 4 areas would be 4 times AI. But that whole area, we'll call that, what do we got here? Q, we'll call it QRS. We'll call that gnomon QRS. makes up all the complements, composed of all the complements that we talked about and the 4 areas. So the gnomon QRS equals 4 times the rectangle AI. We'll go up here to step 14. So we've got the gnomon QRS equals 4 times the rectangle AI. Now let's add KO to both sides of step 13 here. But we can see that KO is the square on AC. So we can say that AC squared plus the gnomon QRS equals 4 times the rectangle AI plus the square on AC. But we can see that AC, the square on AC, plus, which is basically KO, plus the gnomon QRS is the whole figure AF. So all that is the whole figure AF. But the whole figure AF is the square on AD. And 4 times the rectangle, we can see that the rectangle AI is nothing more than the segments AB, the whole original, plus the segment CB, because CB is equal to BI. So we can rewrite 4AI as 4 times the rectangle ABBC. And then we have bring down our AC squared here. So that means that the square on the whole right here is equal to 4 times the rectangle contained by the original whole and the added segment, plus the square on the remaining segment. And this AD was the whole plus the segment, the aforesaid segment, as on one straight line. So I'll just write this down here just for being thorough. Plus AC. So you can see that that matches what we wanted to do in step 2, and we are done. QE